People are always trying to stop heat. From insulating our houses to buying fancy thermoses, coolers, even the clothing that we buy is specifically designed to either control or stop heat. But for all its importance, many people don't even know what heat is, let alone that there's 3 different ways heat transfers. And each of these 3 unique types of heat transfer has its own particular way to stop it. Hang out with me today as we learn how to beat the heat. Now, first of all, what is heat? Well, scientifically speaking, heat is the energy that is transferred between 2 objects that are at different temperatures. Now, it's important to note that heat always moves from warmer things to the cooler things. You can't get coldness. You can only gain energy from a warmer object. For example, when you touch a surface that's cooler than your hand, you can think that you're getting some cold. But actually, it's your hand that's transferring heat. It's giving away your thermal energy to the colder object, and that is why your hand feels cold. Remember that important point. Heat always moves from warmer objects to cooler objects. Now, the first way heat transfer happens is by something called conduction. Conduction is heat transfer by collisions between the molecules or atoms of a substance. Objects must be in direct physical contact for this type of heat transfer to occur. Let's take a look at a spoon, for example. Now, although it looks like it's one solid object, it's actually made up of many tiny moving particles. The faster one of these particles is moving, the more thermal energy it has and the warmer it will feel. Now, conduction is when faster moving particles bump into nearby slower moving particles and speed them up. In this way, thermal energy spreads through an object or between objects that are directly in contact with each other. So going back to the pot on the stove, the fast-moving molecules of the burning gas speed up the atoms of the metal pot. Then these particles spread their thermal energy to the molecules of water, which in turn spreads it to the spoon. Now the atoms of the spoon bump into each other and spread the heat up the handle. If you keep the spoon in the pot too long, it may actually get too hot to touch. Ouch! That's fast! That's right. When we say that something is hot, we actually mean that the molecules of that substance are moving painfully fast. So how do we stop heat transfer by conduction? Well, coolers are particularly good at slowing this type of heat transfer, so I thought I would take a closer look at mine to see if it could help me understand. Surely there must be some magic that keeps heat from getting to my cold drink. I delicately dissected the cooler and found that inside there was no secret sauce or wizardry. Instead, I found air pockets and insulation. You see, insulators are materials that have molecules that are often spread far apart, which makes it less likely these molecules will collide and transfer their thermal energy. Air itself is a pretty good insulator if it's trapped in spaces where it can't flow around. In fact, when I looked at insulators under a microscope, I found that they were mostly little pockets of trapped air. Now, believe it or not, there's something that works even better than insulators at stopping conduction. What could that be? Well, a space that has no molecules at all. That's right, something called a vacuum. This isn't a vacuum like you clean your house with. It's a space between objects where the molecules have been removed or vacuumed out. If you think you would have to go to some space lab to see such a thing, you're wrong. Look no further than your insulated thermos. The reason it's so much smaller inside than out is because in the high-quality versions of these, there's a reinforced layer where the molecules have been sucked out. And that's why these vacuum-sealed thermoses have an impressive ability to keep things either hot or cold for a really long time. So the secret to stopping heat transfer by conduction is to stop the molecules from hitting each other. Think insulators, or better yet, a vacuum.